Workplace incidents are rarely isolated, they result from a chain of failures. This incident highlights how environmental gaps, such as missing safety barriers, combine with behavioral breaches like horseplay to create danger. When an operator is focused on machinery, a sudden distraction triggers a startle response, leading to involuntary muscle contractions or loss of balance, which can cause severe accidents. To prevent such events, organizations must implement layers of protection, engineering controls like physical guards and safety sensors to restrict access, administrative policies that enforce no distraction zones, and a robust safety culture where coworkers recognize that professional conduct is a shared duty. Ultimately, sustaining focus is the primary barrier between efficiency and injury. Operators must firmly decline non-essential interactions while equipment is running, and bystanders must maintain a safe distance. This incident was entirely preventable, underscoring the necessity of treating the workplace with the seriousness required to ensure everyone returns home safe. Soil is not a static material. It exerts significant pressure against trench walls. Excavated material piled near the edge creates intense lateral force, and when this weight exceeds the soil's shear strength, structural failure is inevitable. This incident highlights a systemic breakdown, including the lack of pre-excavation geological assessment, dangerous placement of heavy loads, and the total absence of trench shields or shoring. To mitigate these risks, teams must follow the Thurs protocol: sloping, shoring, and shielding. Utilizing trench boxes and mechanical supports is non-negotiable, as any excavation deeper than 4 feet without protection is a critical hazard. Management must view these safety investments as essential life safety measures, not operational delays. Effective response also requires specialized equipment to prevent secondary collapse and ensure all crew members return home safely after every shift. This industrial incident involving high-torque winding machinery serves as a critical reminder of the absolute necessity for robust workplace safety protocols. The technical root causes center on a breach of safety distances at an unshielded nip point, compounded by the absence of automated protective systems like light curtains or emergency interlocks. Furthermore, human factors such as routine complacency and the use of loose clothing significantly elevate risk. To prevent such occurrences, management must enforce the installation of physical guards, ensure the accessibility of clearly marked emergency stop controls, and implement rigorous, recurring safety training. Personnel are equally responsible for maintaining strict adherence to designated safety zones, wearing appropriate form-fitting attire to avoid entanglement, and remaining vigilant to potential mechanical anomalies. Ultimately, integrating advanced engineering safeguards with a proactive safety culture is essential for ensuring a secure industrial environment and preventing future incidents. When a workplace incident occurs because a worker is unaware of an open hazard, such as an unguarded pit, it highlights critical failures in environmental management. When hazards are not clearly marked, depth perception is often compromised, rendering them invisible. Furthermore, long-term exposure to a work site can lead to normalization of deviance, where employees become desensitized to their surroundings and stop scanning for changes. Modern safety engineering must prioritize fail-safe designs that remove reliance on human vigilance alone. Systems should be designed so that even if a worker is distracted, physical safeguards like railings or chains prevent an incident. Management must adopt a notify, don't expect approach, ensuring robust barriers are established immediately whenever a hazard is created. Ultimately, an effective facility is error-tolerant, prioritizing systemic safeguards over individual caution to ensure everyone's safety. This incident serves as a critical case study on the physics of high-pressure systems and the imperative of workplace safety. An inflating tire acts as a pressurized vessel containing immense potential energy. When structural fatigue or damage is ignored, the tire cannot withstand sustained pressure, leading to a violent rupture. The resulting shockwave generates instantaneous kinetic force capable of causing severe trauma. This incident highlights critical human errors, including improper technician positioning within the strike zone and a failure to utilize mandatory safety inflation cages. Compounded by environmental risks and a full sense of security, this routine task turned into a dangerous event. To prevent such outcomes, facilities must enforce strict protocols, Always use steel safety cages, conduct rigorous pre-inflation inspections, utilize extended remote hoses, and mandate proper P. Understanding that every tire is a high-pressure vessel is essential for shifting the professional mindset from speed to safety-first operations. This incident serves as a critical case study on the hazards of confined spaces and the necessity of rigorous safety protocols. Utility vaults and manholes are not designed for occupancy and often suffer from poor ventilation, allowing hazardous gases like methane to accumulate. The explosion followed the combustion triangle: accumulated gas, oxygen from the site opening, and an ignition source. This failure was compounded by hazardous technician positioning and the absence of mandatory pre-entry gas monitoring and forced ventilation. Complacency or the normalization of deviance often leads workers to treat these high-risk tasks as routine, bypassing essential safety measures. To prevent such incidents, facilities must enforce the assume hazardous rule, mandate atmospheric testing, utilize mechanical ventilation throughout operations, and implement spark-proof equipment. Safety must always prioritize procedural integrity over speed to ensure every worker returns home safely. Industrial incidents often stem from systemic failures rather than isolated human errors. Trailer creep during loading shows that relying on truck brakes is insufficient. Facilities must use automatic dock locks to prevent dangerous gaps. Meanwhile, mechanical entanglement and friction-induced fires in machinery highlight the need for safety trip bars and strict lockout-tagout procedures to de-energize equipment. Furthermore, unprotected floor openings demonstrate a critical lapse in change management, necessitating an absolute no-guard, no-work policy. Collectively, these events reveal a reactive safety culture. To move toward proactive risk management, facilities must engineer fault-tolerant systems that protect workers even during lapses in vigilance. By retrofitting machines with automatic interlocks and enforcing rigorous physical safeguards, businesses can mitigate risk through robust engineering rather than relying solely on individual caution. This incident serves as a critical case study on the mechanics of heavy equipment stability and the imperative of strict operational protocols. Telehandlers possess a high center of gravity, which becomes dangerously unstable when forks are elevated or when the machine is operated on uneven terrain. Executing a turn while traversing an incline generates centrifugal force that shifts the center of gravity outside the machine's stability triangle, inevitably leading to a lateral rollover. This incident highlights fundamental operational failures, including turning on a slope and a lack of situational awareness regarding terrain hazards. To prevent similar occurrences, facilities must enforce strict safety pillars, maintain forks at the lowest possible position during transport, travel straight up or down inclines, and conduct rigorous pre-operational site assessments. Professionalism and adherence to safety protocols are essential to ensure that heavy machinery remains an asset rather than a hazard. Industrial incidents often stem from systemic failures rather than isolated human errors. Trailer creep during loading shows that relying on truck brakes is insufficient. Facilities must use automatic dock locks to prevent dangerous gaps. Meanwhile, mechanical entanglement and friction-induced fires in machinery highlight the need for safety trip bars and strict lockout-tagout procedures to de-energize equipment. Furthermore, unprotected floor openings demonstrate a critical lapse in change management, necessitating an absolute no-guard, no-work policy. Collectively, these events reveal a reactive safety culture. To move toward proactive risk management, facilities must engineer fault-tolerant systems that protect workers even during lapses in vigilance. By retrofitting machines with automatic interlocks and enforcing rigorous physical safeguards, businesses can mitigate risk through robust engineering rather than relying solely on individual caution. This incident serves as a critical case study on the hazards associated with managing high-density industrial materials and the necessity of rigorous workplace safety. Granite and natural stone slabs are prone to sliding due to their density and low-friction surfaces. When stacked, a shift in one unit can trigger a massive domino effect chain reaction that no human can restrain. This failure is often compounded by improper positioning in the strike zone and the reliance on manual handling for loads that require mechanical assistance. To prevent such incidents, facilities must enforce a strict strike zone prohibition, ensuring personnel never stand within the fall radius of materials. All heavy lifting must be substituted with mechanical equipment, and racking systems must undergo periodic load testing. Workers must be trained to identify potential fall paths to ensure that industrial materials are handled safely.